Hello everyone, welcome back to another interesting question on center of mass frame taken from Pathfinder. Let's read the question. A small bead of mass small m equals to 4 kg bead. It's threaded, right? And it's also small, meaning you can neglect the rotational inertia of the mass. And it is threaded on a homogeneous frictionless ring. Friction is neglected, okay, of mass 6 kg and radius 0.5 meter. So there is a ring and there is a bead which is threaded. So drawing the diagram itself is a part of the solution in this question. Initially the system rests in free space, no external forces, gravity, normal reaction, all those things you can neglect. Now the bead is struck. To impart it, a velocity u equals to 5 meter per second. Bead is struck, not the ring. Only the bead is hit, and that too it is hit tangentially. That means only B moves because of that impulsive force and gaining a quick 5 meter per second velocity. Okay. Now the question would be, find magnitude of force of interaction between them, between the ring and the bead subsequently, once the hit is given after that. And subsequently we also need to find the minimum kinetic energy of the bead. That's what they are talking about. So there are two things they are asking. What is the magnitude of force of interaction between them? And here there is no friction, meaning only normal reaction you will have it, and that is going to be always directed radially. And also subsequently bead kinetic energy minimum value. So there is a transfer of energy from bead to ring because of the interaction between them. There is no loss of mechanical energy here. But anyway, so this is a question we have. What I will do is, first let us take one parallel question, a simpler one. This is actually something you are supposed to know it pretty well. Any JEE serious advanced aspirant should have these things pretty comfortable. I am just going to repeat it now. Let's consider 2 point masses instead of ring and particle. Let's consider 2 point masses connected by a string, let us say. There is a string here connected by a string length L, and m1 and m2 are there, and I am giving a sudden velocity to u, to m1, u velocity is given. And immediately at that moment m2 would still be 0, having 0 velocity. So that is going to be at the center of rotation, instantaneous center of rotation. So the velocities would vary linearly up to that point m2. m2 will have 0 velocity, m1 will have u velocity, and you can actually find the angular velocity of this entire combination v relative perpendicular upon separation. This has no velocity, relative velocity is only u perpendicular to length of the string there, and then separation is L there. U by L would be the angular velocity, I had mentioned it here, and Vc, let us say C is the center of mass here, Vc will also be there. We can find Vcm using a conservation of linear momentum, otherwise velocity of center of mass equation, m1 u1 plus m2 u2 upon m1 plus m2. So u2 is 0 here. So Vcm is this, and then the center of mass will divide the line joining the internal intercept here, r1 and r2 ratio. So that r1 plus r2 equal to total length of the string, and m1 r1 equal to m2 r2. These are very simple results. By solving this, you will get r1 depends on m2, r2 depends on m1. So r1 and r2, they are inversely related to their respective masses. This is another thing. These are all very standard results. You are supposed to know them very well. Now with respect to center of mass, if I go to center of mass is the inertial frame here, because velocity of center of mass will remain constant. There is no other external force here. With respect to center of mass, they are supposed to go in circles. Separation between them is fixed. Separation between C and m1 is fixed. C and m2 is fixed. When separation is fixed and they are moving, that means only possibility is circular motion there. Otherwise there will be translation. Translation is not allowed because in CM frame C is stationary. So they go in concentric circles where C is the common center there, and T, the tension force that is created there, that is the first question they are asking, magnitude of force of interaction, that is a tension here. Of course we are dealing with a slightly different question, we will get back to the original question, but before that this is a prelude. So T equal to mass of the particle 1 into acceleration of particle 1, centripetal acceleration, which is omega square r1, otherwise mass of particle 2 into centripetal acceleration of particle 2. So either way you substitute r1 or r2 here, you will get m1 m2 upon m1 plus m2 times u square by L, where m1 m2 upon m1 plus m2 is generally called reduced mass. I use m star as a symbol here. Mu is generally used for coefficient of friction, so I avoid that symbol. m star into u square by L. This is going to be the tension developed there. And with respect to center of mass, because they are going in circular path, you know that velocity would be r omega, speed would be constant throughout, but direction is continuously changing there. So V1 cm is r1 into omega, V2 cm equal to r2 into omega. These are the V1 cm and V2 cm here. With respect to center of mass, they'll have. These are all very simple standard results. Students should know them by heart. Like you would have done so many questions using these ideas. But anyway, I am just repeating them again. Now, when you go to finding velocity of one with respect to ground, now we were looking at with respect to center of mass here. When you come down to ground frame, you would be adding velocity of center of mass to that vectorially. So that's what you have, that we are showing it in vectorial form here. VCM is always in one direction fixed here, but V1 cm magnitude is fixed, but direction is continuously rotating. That theta is the angle at any position there. So the resultant of these two is going to be V1, that is from triangle of vector addition. Now they are asking V1 minimum. When would V1 be minimum? You see these two vectors are there. One vector has got fixed magnitude in fixed direction. The other vector has got fixed magnitude, which is V1 cm. We have already calculated, you see here. But it is continuously changing direction. When will they be maximum? When they are in the same direction. When would the resultant be minimum? When they are opposite to each other. So when theta equal to 180 degrees, that's where you will have the minimum value. And so the magnitudes you take the subtraction there. And that's going to be this one, m2 minus m1 upon m2 plus m1 into u. So this is a situation we have discussed now, two particles connected by a string. Now let us come to the original question given now. So instead of the string, we have a ring here, and the particle is only one particle. Other particle is, instead of particle, we have ring here. So now center is at O, center of the ring, and we have projected it. Now this can be equivalently assumed as two particle system. M1 is azimuth and M2 can be visualized as concentrated at center of mass, and the separation between them is R there, and that contact force, instead of T here, you should have normal reaction here. This is going to be normal reaction. Let me read that. So this is not T, this is going to be normal reaction, because what you have is a contact force here. So m star we calculate reduced mass m1 m2 upon m1 plus m2, 4 kg, 6 kg they had given. U is given 5 meter per second. So this is like a few seconds question actually, if you know these results pretty well. N is obtained there. Now V1 minimum would be how much? You can calculate by using this m2 minus m1 upon m2 plus m1 divided by u. So that also you can calculate. Just substitute 10 minus 6 minus 4 by 10. So that's going to be 2 into 5, right, divided by 10. So 1 meter per second will be the velocity there. So this is a very simple standard result. Yes, definitely when you are solving it from the scratch, it will be pretty lengthy, but it is a built up question. Already certain standard results students are supposed to know pretty thoroughly. Just in the place of particle, they have given a ring, that's all. Otherwise, it's a very simple question. I hope you understood and you revised the concept here, which is very important concept. So with that, I'll conclude here. Thank you very much for your time. Until next time, goodbye.